Ah, the sound of the start of class. Isn't it just beautiful? Absolutely beautiful. Happy Thursday, each and every one of you launch coders out there. Welcome to another fun, exciting, magical, amazing. I'm really lacking on creative adjectives right now, but you know what I'm getting at. It's going to be a fantastic time tonight. We're going into functions round one. Yes, there are multiple rounds, and I'm so excited. Functions are things that help life just be easier in the coding world. Oh, the coffee though, like seriously, great touch there tonight. All right. Yes, welcome to functions, everyone. But before we, of course, dive into functions, let's do something else. We're going to do announcements. Here we go. I think you all know at least one of them coming up here. First things first, part 2. It is the 20th, y'all. I know January 2022 is almost done. If that doesn't give you the scaries, I don't know what does. I just realized that. I'm like, oh my gosh, 2022 is already a month in almost. But part 2 is due. That should give you even more scaries. Make sure that is finished. There are only 3 parts, and the third needs to be done by the 24th, aka the entire assignment needs to be done by the 24th at 5:30 p.m. This is not a joke, and nor is it a drill. Make sure that this assignment is done by that time. That is a strict cutoff date. I heard the question in the beginning of class, does it have to be in and working? For the most part, yes, it needs to be turned in and have a very obvious try at it. If there's one small thing found out there, Clark will always address that. But for just your peace of mind, make sure that assignment 1 is working by January 23rd if you have to. Whatever you need to do to get that assignment done, reach out to your colleagues, reach out to your TAs, reach out to me, get some time on anybody's books and help each other out. I'm always here to answer questions. I've already met with students, or I had some students reach out. I'm happy to continue to help. Love working on assignment number 1 or any of the assignments or answering any general questions in general. Couldn't think of another word for general there.
I have one question.
Jody. Yeah, Jody.
Who was the guy at the beginning of class? And I'm not trying to call anybody out, but who was it that was asking for help that said they might message me on Slack? I just want to know.
So it was me. It's Henry, Jody.
Okay, Henry. Okay, I just wanted a name to put with the, just because.
Okay. All good. All good. So. Awesome. All right. Cool. Yeah, and also too, feel free to continue to talk on the channels too. If you want to help out other students out there, throw it on the general chat. Say you're out there for everyone else, like that you are willing to help. Jody, I heard you in the beginning of class. You're willing. That's awesome. Help out other students. Remember, post that in the general chat. Get that conversation going. Help out your fellow colleagues. It's great to just throw ideas off of each other. So awesome, awesome. So yes, any questions about assignment 1, feel free to reach out to your TAs or myself, fellow colleagues. Continue on. Of course, we have studio review tonight at 8 p.m. I'm going to be restarting up class at 8 p.m. This lecture was what I'm talking about, not class in general, but just this Zoom link, and I'm going to be going over that studio. As always, it's recorded. Excuse me. So feel free to join in on the fun. Oh, it's just so much fun. Love all the questions too when we get on there. We get to just chill. I actually get to sit down. It's an amazing time. Amazing time. All right, two more things I need to talk to you that I don't have nice little slide things for. Don't forget to, that is not the right sticky there. Don't forget to submit your survey. They are going to be due, I believe, by today, Clark said. So please, if you have any feedback, send it over to Clark. I love to hear any kind of feedback possible on my end too. I know I do not teach perfect for everyone, so anything I can do on my end, feel free to, of course, submit that feedback with that in there. Reach out to me directly, send me a private email, whatever you want to do. I know I'm not perfect, so please tell me how I can help better this lecture for you. I already got one. Yes, eventually, I promise I will get a closet door there. It's coming. That was one offer, I know. It will be here eventually, hopefully, whenever IKEA says green light. Yes, I love IKEA. That's also a small thing. Anyway, what else do I have to do? Oh, yeah, one more thing. Okay. So yes, that is it. Please fill out that feedback, send it back in. And then finally, one thing I wanted to call out also is that during tonight and anytime we're using Slack too, don't forget that hashtag announcements are for announcements. So that if there is maybe a link that was talked about in lecture that really needs to be shared and no one has shared it, any TAs or the instructor or Clark, that's when we'll post in there. If you have general questions about the assignment or anything along those lines, feel free to reach out in either general, go ahead and put that in lecture chat, or any other channels that are created by you or the community. So just leaving announcements open. If you do want to talk in announcements too, feel free to, again, reply in the thread, which leads me to my last thing. In lecture questions too, just want to do a quick reminder. We talked about it a little bit last lecture. If you are in the lecture questions channel and you are having a conversation there, just remember to keep those conversations in the threads. If you are looking how to reply in the thread, if you go and highlight over, and I'll go ahead and just quickly show this. If you go over here into our lecture questions and we see that there's a question here, will there be other cutoff assignments after this one, which hopefully I think that was answered today. What we're gonna do is just click in reply in thread there. And then just type out your reply there. That will keep all of the answers for that particular question in one area. So if you're looking for it in the future, it's all nice and organized right there. Thank you, TA Sean, for showing that example. So yeah, we just like to keep that all contained under this question. So one, we all know it's been answered, and two, we can find the answer a lot easier. So it makes it better for all of us. If I do see one out there, I might have to just either push it off to the side or something like that. So if it does, yeah, we just try to keep it in the reply area. Awesome, awesome. All right. So remember, just highlight over that, click on reply to thread, and that's how we do that in lecture questions. Don't forget, if there's anything general, just talk in lecture chat channel. Awesome, possum. Any other questions or thoughts or concerns anybody would like to bring up before we hop into stuff?
I'll point out real quick, Kyle, with your audio cutting out there a few times for 5 or 10 seconds at a time, that these guys don't know that when you upload it, usually your recording has all the bits that cut out.
Thank you for that. And let me know if I continue to glitch tonight. I've been having weird spectrum issues lately, and I am directly lined into Ethernet right now. So let me know if I keep glitching out. That is not fun at all. All right. But yes, you are absolutely right. My recordings will be just me talking to the screen without any glitching whatsoever. So I apologize for that. Please let me know if I glitch out on something big. Yes.
I have one question. This is Mr. Tonight, when we're using Replit tonight, do you have posted where we're going to be starting from on that for the functions chapter 10?
Posting exactly.
Is that
So what are you
into?
We'll be going into functions. Yes, that is the material that we have, or yeah, that's the material that is the reading stuff, and that we'll be diving a little bit deeper into today. Yep.
Okay, and then this chapter is broken up into 2 parts?
It'll be 2 parts. So
chapter
this
10 is
one,
broken up into 2 parts.
correct. So on our launch code canvas there, we should see that our reading, we have 2 different readings, I believe, for functions. So we have tonight where we're just beginning to touch the tip of the iceberg, and then round 2, we'll be going a little bit deeper diver into it.
But all for chapter 10? Or are we going into chapter 11 when we start up on Monday?
I don't exactly know the
Chapter
particular.
11.
Is
Chapter
it chapter
11 is Monday.
Okay.
Chapter 10 is today.
Okay.
But you need neither of them to do the assignment, the immediate assignment 1. You need to know functions exist, but you do not need to know how to do functions in order to successfully do assignment 1.
Thank you.
Thank you.
I appreciate that. Because I'm traveling right now. I'm actually in Pennsylvania, and I had printed out chapter 10, and I'm going to still be in Pennsylvania on Monday, the 24th. So I need to figure out what I need from Monday, because I did bring some of my documentation with me, but now that I know this, I will update it because I wasn't following the syllabus properly. Thank you for the clarification.
All good, all good. Awesome. Thank you, Clark.
I just want to say, Henry, I shot you a personal direct message in Slack. So.
All right, everyone. In that case, as there's no more questions looking here, let's go ahead. And Madison, I apologize for glitching out. I am just, I'm bugging out for some reason over here. Hopefully it gets better. Fingers crossed. Okay, let's go ahead. And one quick thing before we actually start diving into lecture, it is actually about last lecture. And I want to kind of talk about one last thing that I had a few questions on directly messaged, people directly messaged me. And this is about arrays. And I'm going to go over here. We're going to go to a Replit here. So real quick. So we talked about arrays last time. But one thing I want to really clarify is that I'm going to type out an array here. We're going to say, in this one, I forgot what it was like. We're going to say dog names. Stark. And then we have Bella. And then I know I mistyped Bella there. And we're going to have another one called Toby. Awesome. All right, so what we talked about last week is that when we define an array like this with a const, we're not able to change the container, but we're able to change the contents. And when I said this, it might have gotten a little confusing sometimes on the animation. They're just in the general explanation of what we were talking about. So real quick, what I want to do is show how we can change things and how we're not able to change things in a very, very, very quick example with this arrays. So as we see here, we see this const dog names. Now tell me this, can const variables change?
No.
They cannot. Very good. Yes, we cannot change const variables. When we assign a constant variable, it will never change. When we assign something, it means we're putting this equal sign here and then something on the right-hand side of the variable. When I assign maybe const dog age equals 7, I just assign the number 7 to dog age, a constant variable. So the age will never change, which is not possible, unfortunately. Dogs unfortunately have to age, but just wanted to get that point across. The same with dog names. I said dog names is now equal to this array of stuff here. That stuff are some dog names inside of it. So what I'm getting at is that this array will never be able to change, but the contents will. So let's go ahead and try to change the array. When I say dog names equals a new array saying pizza, and why not just whatever, bread. I know that's boring, but whatever, we'll just do that one. When I run this, what just happened is that I'm trying to reassign dog names to a completely different box, container, array. When I run this, I'm going to get an error on the right-hand side. Assignment variable, or assignment to constant variable. I'm not able to set dog names. So how exactly can I change my array up here? How can I change the contents? And that one is exactly how we talked about last time. We can use a couple things, but the first thing we use is bracket notation. I can change my 0th index, which is Stark here, as remember it's 0, 1, 2. I can change it from Stark to now pizza. In this way, what I'm doing is not changing the array, I'm changing the contents of it. Now remember, an array is not necessarily data, it's more of a data container. It is a box of stuff inside of it. So we're not changing what the box is, we're changing the stuff inside of the box. So we say dog names here. And then we run this. And if we see to the right, we don't get an error, which is what we're looking for. And even so, we change Stark, which is at index 0, to pizza, and then we print out dog names, so the whole array. So we see pizza, Bella, and Toby. So again, what we did here was we changed the contents, not the container. The container is what is constant. The container denoted by these open and close square brackets. So that is what I wanted to get out there. So any questions about those two kind of, I guess, yeah, kind of weird small caveats to this?
So I get the concept of being able to reassign the individual item in the array, but what's the practical use of establishing Stark in an array to change it on the next line of code?
This right here is absolutely useless. It's mainly just for example. You would typically not do this. You would not change it on the next one down there. Otherwise, I would just want to combine these two lines and just change Stark to pizza here instead. This is really just for example's sake. It wouldn't be best practice to typically do this. It's really just to show it. Yeah, sorry.
No, you're so good. That's kind of what I figured. As a follow-up question, what would be a real-world situation when you would need to update the contents of an array?
Yeah, absolutely. So instead of dog names, which don't usually change, we can say dog ages that correspond with the particular dog in that. So let's say we'll keep dog names there. We'll make another array that says const dog ages. And this one will say 7, 4, and 8. So what does this exactly mean? At the 0th index, we have the name Stark. At the 0th index, we have 7. I'm saying Stark is 7 years old here. Every year, what I'm going to want to do is I'm going to increment 7, or whatever dog has their birthday, to another number. So down the line of my function, or down my line of my application, that's just waiting for a birthday to happen. So if it is Stark's birthday, we increment our dog's age by 1. So in that case, what we'd say is dog's age 0 equal dog's age of 0 plus 1. So what I'm saying there is that you will need to find a situation in which we don't have a constant variable or a variable that stays the same. Birthdays or excuse me, ages will change. Bank account information, so bank account amounts will change. Stuff like that, but you still want to contain all of them in one container because they are related. So that's kind of what it is if you have information that's changing, but it's also related, in that case, that's when you're going to want to update the contents of your array. You will find situations like this. You just have to be able to know what to do in those cases. Does that kind of make a little bit better sense?
100%.
Awesome. Okay. Awesome. So I just want to go over that really quick. We've done this for 3 lectures, so I just really wanted to do a very, very quick touch on it. Raiden, I see that you asked a question, how do you release a constant from memory? Constant from memories will automatically be removed once they are out of the context. So if you have a constant inside of a for loop, once that for loop's over, the variable will go away. If you want to just remove a constant when you're inside of an application, there's no way we're really going to talk about doing that. If you want to look it up, feel free to search that exact question. But it is slightly difficult to remove that memory allocation, essentially what it's called, from your application if your application is running, if it's a constant. There's also no big reason you'd want to. JavaScript will usually do that stuff for you. That will be under the title of garbage collection if you want to search that name too. It is actually called garbage collection, I promise. All right. Awesome, awesome. Fantastic, everyone. All right, that was a small little example. We are done with announcements finally. Longest announcement thing in the world. Are we all ready to get into the fun stuff? Silence means heck yes. All right, heck yes. Let's get into this thing. Answer me this. Everyone remembers the most famous of variables in these lectures. How can we create dog name and set it to start? Who can start me out? Everyone's like, oh, this thing. Yes.
Dog name.
Const.
Dog name.
Ask yourself, does a dog name change? No. Const. Thank you. Const
No.
dog name start. Guys, we've done this variable every day. Come on. Whatever. Every lecture. You know this. Yes. Const dog name equals start. This is what happens when Kyle has coffee during lecture. Let's do this. Absolutely right. Continuing on. Say I assume dog name will change in the future. Yes. Trick question there. There we go. Plot twist. Absolutely right. We use the keyword let if it's going to change or be reassigned down our lines of code. Awesome, awesome. So you want to reassign dog name now to Toby. How would I do that?
Dog name.
Very good. Dog name equals Toby. This is a reassignment. This is a reassignment. It's when we're not creating the variable. Remember, when we create a variable, we use the word let. We use the word const. In this one, we're reassigning. So we say dog name equals Toby. Awesome job. Let's keep going here. Let's ask our user for a dog name instead now. So we're actually going to ask the user, what's your dog's name? What's the first step we need to do in order to do this?
Const.
Const. I like that.
If you're asking a question, you need
require readline sync.
Very good. In this case, we're going to be doing a read line sync. Absolutely right. And up there is why I put const. We need to import that package, read line sync. So in this case, I'm going to call it ask the user. Remember, input, what you see in your assignment and most of the exercises, is just a name. It's an arbitrary name that you can create whatever you want. Input doesn't have to be input. In this case, I'm going to call it ask the user. It says equal to require read line sync. Remember, your variable names can be whatever you want it to be, as long as they're unique. Awesome. So for this then, how do we ask the user for a dog name now that we have readline sync in our project?
Ask the user dog name. Dog name is equal to question.
I love that. Dog name is equal to ask the user. I gave you that. What else? What's that?
Question.
I got it. I got it. Awesome. Yes. Dot question. Very good. What's your dog's name? Great. Yes, this is exactly how we do it. Remember, start by bringing in that package. If you don't have this readline sync package, there is no way you can ask your user a question and get their answer back. So this was kind of a two-part thing. You need readline sync to help us out, and then ask the question using ask the user dot question and providing the question inside those parentheses. Awesome. Now let's do it a little bit further. Would this work?
No.
No.
Why not?
Dog name is already
The dog name is-
declared.
Exactly right. Yes, the dog name has already been declared 3 lines above it. Remember, our variables have to stay the same when they're created, or sorry, stay unique when they're created. So we couldn't recreate the dog name variable with that word let, because it's already created with about 2 lines up there equal to Stark. So no, we could not do this. Awesome job. And then after this, we would console log the dog name out. So in this case, to help me out here, if I gave the input Bella, what would the output be?
Bella. Bella.
Anybody else got a different answer? Kyle's being a trickster. You're absolutely right. The output is Bella. Absolutely right. Because as we go down this code, we bring in readline sync on that first line. We assign, or we create the dog variable, or sorry, we create the variable dog name equal to Stark. We go down to the next line, we reassign that dog name variable to Toby. Third line down, we ask the user, what's your dog's name? We said Bella. And then we place Bella and reassign it to that dog name variable. Finally, we console log that dog name variable, which the value is Bella. Hence our output would be Bella in this example. Fantastic, everyone. Any questions about these?
Kyle, like, suppose all this code is in a function, and the function takes dog
We're
name.
gonna pause right there because we don't even know what that F word was. So
Okay.
I love the enthusiasm, but let's hold it just for a little bit. Don't use F words right now. That's not appropriate. Let's keep going forward. What if we wanted to create an array called My Dogs, which includes Bella, Stark, and Toby? How would I do this?
My dog.
My dog. Let
Well,
my dog.
I like let, but in this case, I'm just gonna be using const. There's
Const,
no issue with
okay.
that. That's completely fine, completely fine. So const with this one, and I heard my dogs. Awesome. Then what
Then-
symbol do we start with? To
Square bracket.
Very good. The square bracket, then we include the information inside of the square brackets. Remember, we always separate our, always separate our data with commas. So we do Bella in quotes because it's a string, Stark in quotes, Toby in quotes, but we separate them with commas. Awesome, awesome. Now help me out with this. If we want to loop through each dog and print it out to the screen, how in the heck are we going to do this?
For loop.
I love it, a for loop. Yes, we need to loop over something, and this is an array. So we need to loop over it with some kind of tool. A for loop is usually what we utilize to loop over arrays. So awesome job. All right, so we have for. What comes next?
Parenthesis.
Very good. And my finger accidentally pressed the space bar twice, so I gave you that too. We say let I equal 0, our starting portion. What does I actually stand for?
Index.
Very good. Absolutely right. Thumbs up. Yes, index. Very good. So index, our starting index is going to be 0. What do we separate all of our stuff here with in the for loop?
Semicolon.
Yes, semicolon. So next thing is that we need to loop until something. What is that? So I is less than 1.
My dogs dot length.
Very good. The length of the array you want to loop over. Very good. The length of the array you want to loop over. Awesome. My dogs dot length. And then next.
Semicolon. Then I plus plus.
Very good. What we should do between each and every iteration. We need to increment I. We need to increment the index. Excuse me. Awesome. All right. Then finally, we need to console log it. We need to print it out to the screen, but what do we need to put inside of the console log?
My dogs of I. Then
very good. I heard my dog's square bracket of I. Let's close that. Fantastic. Yes, we need to call out the individual indexes of the my dogs array using that I, which again stands for index. So as it iterates 0, 1, and 2, we'll print out Bella, Stark, and Toby. Fantastic. All right, one last thing here. While looping through print out Toby, or excuse me, while looping through print out, who let you out, Toby, if the dog is Toby?
Console.log. My dog.
No, we're not going to be doing that. What are we doing here in this question? While looping through, very good. We're asking a question. Is the dog Toby? And if so, do this. So you're absolutely right. We need, in this case, start with an if statement. So I'll even help you out there. If my dog's square bracket I equals what?
Toby.
Very good, Toby. And then we actually need a console log. Toby who let you out. Very good. So remember, when we are asking a question, we need to use an if statement. If we need to check something, validate something, we need to use an if statement. In this case, we are checking to see if my dog at index I is Toby. And if so, we're going to console log that message. So awesome. Fantastic. And let's go ahead and we're going to just go ahead and see and make sure all this stuff works. We're going to come over here. We're going to run this. So we're going to run this over here. It's going to load up everything. Just make sure that it actually works. So as you see, we did the ask the user. We required the read line sync. We are setting the dog name to start, but then we're going to reset it to whatever the name is. So in this case, I'm going to say my name is Bella. Looks like that also works. So this portion works up here, the first example that we did, and then it says Toby who let you out. And what that was doing is that it looped through and eventually at index, what index did it find Toby at exactly?
Index
2.
2.
Index 2. Very good. So at index 2, it found Toby, and then it printed out Toby who let you out, which we see right there. Awesome. So our 2 examples are working so far.
I got a quick question about that code right there. So if you wanted it to still loop and say the names, would you just do the console.log my dogs I, and then also at the bottom of that put the console.log like after the my dogs I equals Toby, so that it will like list them one by one, and then once it gets to Toby, it would say Toby who let you out.
So if you wanted the dogs to appear on every individual line, every single dog, we'd have to do it outside of the if statement. So we can do it on the top of the if statement or below it. Because if we did it inside of the if statement, what is the only dog name that will print?
Toby.
Bella.
It'll only be Toby, because we are only looking for Toby inside of this conditional. So we placed our console log here, and I'll show you what we're doing here. My dogs I. The only dog name that will print, if we look at it, after I type that in, is Toby, because we did it inside of the if statement. And remember, this if statement will only let you in if the dog's name is Toby, as we see from this conditional here.
Absolutely.
The
How
side.
would you do it? Sorry.
Yeah, Annie. No,
How would you do it if the user had to print out Toby? Like if those were both in the same thing.
So what do you mean by the user had to print out Toby?
Like, what's your dog's name? And the user had to say Toby, and then it had to respond, Toby who let you out. And
So
if you didn't say Toby, it wouldn't say that.
So in that case, we're not even using the my dog's array then. What variable would we be checking instead if we're checking
Dog
the user's
name.
input? Exactly right. We're checking the dog name up here because that's where it comes back in from. Remember, ask the user.question gets that information from whatever the user said and then stores it into the variable on the left-hand side here, which is dog name. So if we wanted to actually do that, what we do is that we put it up here and we say dog name right here. Just like that. So now if we run this, and I say Toby, we'll get actually who let Toby out twice. Once from right here, and once from down here. Does that help out, Annie?
Yeah.
Awesome. All right. Any other questions before we move on? All right, go real quick. John, I thought the I in the loop was just a variable. It didn't stand for anything. John, yes, you're absolutely right. I just kind of helps out by standing for index. It's not like truly abbreviated for index all the time because you can use J and K. But to help us remember, I does kind of stand for index when you're first looping through the for loop. But yes, you can always, it's just a variable. So it's an arbitrary name. You can change it to cookie, pizza, whatever, or JK, etc. for sure. But usually I kind of stands for index in that because we're usually just looping through the array one time. So that's where I was going with that. All right. Okay. I can't really look at a specific example right now. Tracy Ann, if you want to in the very end, if we still have time, remember, just call me out and we can stay behind and take a look at that example. All right, let's keep on going. So what we just did there was that we went through and we prompted the user for a dog's name, which is awesome. We got a dog's name back. We didn't really do much with it, but whatever. We'll put that off to the side. And then we did a second thing. We looped through an array of Bella, Stark, and Toby, and we just printed out, Toby, who let you out? Whenever Toby's name was found in that array. Cool. But in the end, if we look at these two things that we did here, we asked the user for a dog name, and then we come down here and we loop through that array, we just checked for Toby. Now, are these two things, were they even related in the example? No. What we did is that in our one application, we created two tasks. Two different tasks, two different things that did two different things, basically. So what it was doing is that one was asking for the dog's name, the other one was checking for Toby. I can get to that in a little bit. Can't really take a look at it just right now. I apologize. If a TA is on there to answer that question, I would greatly appreciate that. All right, so yeah, we created two different parts of our application that have two different tasks. Awesome. That was easy enough. Replit allows that. We were able to see enough code. I mean, if we come and look down here, that's not that much code. It's 9 lines, barely even double digits. That's cool. But in coding, are we always just going to be asking for a dog name and then looping through a random set of arrays? No. So there's kind of a dilemma that we have to deal with in programming. The biggest thing is, what if we wanted to add more tasks? In applications that you have across anything that you work with on your computer has lots of tasks, lots and lots of tasks. Get your user information, go get the bank account information, do something with it, increase this person's funds, sell this stock, adopt this dog. Lots of tasks are out there that one application does. So if we want to add a lot, that's going to add a lot of code to do a bunch of things in just one thing that goes very, very sequentially right through all of the code. And then the other thing is, what if we want to ask for a lot of dogs or loop through it and find Toby a lot of times? What if we wanted to do the same exact task again? What have I been telling you from the start? Developers are extremely, extremely lazy. We don't want to keep typing out the exact same code every single time. I just want lunch to come and go get my Subway, come back and do something different. That's all I want to do every single day. Hence, we don't want to repeat our code. We want to have something out there that can help us minimize our code and let us kind of reuse our stuff again. So if we don't have this thing, our code is just going to like basically grow off the screen. We have millions of lines of code that just do the same exact thing. That's not cool. So why am I yelling at you all about this? Essentially, we need to discover something that can help compartmentalize our code. And I'm very proud of myself right now because last time I did this whole lecture, I could not pronounce compartmentalize. I was literally practicing in front of the screen before class to actually pronounce this correct. Look at that. It's like 5 syllables. That's a lot of syllables. All right, anywho, so we needed something to compartmentalize our code. So it actually chunks it up to what it needs to be or what it's actually doing, that particular task. And another thing is that it needs to be reusable. Remember, save the planet, recycle. We want something that's reusable. We want to be able to repeat a task if it is a necessity. So if we want to continuously look for Toby, if we want to continuously ask the person for a dog's name, we can do that without having to rewrite a lot of code. So what is this magical thing? Is there anything out there that we can possibly use? Maybe it was the name of the lecture. Yes, you're absolutely right. It was functions. Functions is that magical tool that we are able to separate our tasks from each other. Like we saw in that example, we have 2 different tasks we were doing. Asking the user for that dog name and looping through an array. Completely separate things. 2 different tasks. Hence, we can make 2 different functions for those. Not only that, not only can we compartmentalize with functions, but we're able to repeat our code or reuse our code, recycle our code. So if we need to do the same exact task a million times, we can do that very, very simply. Excuse me, simply. Yes, the dreaded F word, functions. So yes, this is it. If you're actually thinking about, okay, what exactly is a function before we dive into it? Like we kind of talked about with our recipes, like we were building a cake to begin with. Say you're like, I don't know, making dough for bread. You're gonna still mix those ingredients. You're gonna mix them up, but then you're gonna need the dough. Kneading the dough is a task, and you need to continuously repeat that task, kneading the dough until it is completed. That right there is your first function in a bread recipe. You consistently are doing one thing over and over. You're repeating that task. Hence, you are having a function you're able to repeat over and over the same exact methodology. So that is a quick introduction into functions. One big next thing I really want to dive deep into. Functions are a kind of newer thing to us because just like variables, you create them and just use them. For if statements, you create them, use them. For loops, create them, use them. But for functions, you create them and then you call them. You do two things with functions. You create them and then you call them. So just like the typical cycle of life, we need to talk about creating first. So let's go ahead and dive into how to actually create a function. So let's do that. We're going to bring back that original example by asking just the user for the dog name here. So as always, we ask the user using readline sync. We create the let dog name equal Stark, and then we ask the user, what's your dog's name? And they reply whatever back. It reassigns dog name there. But let's take this thing that was just randomly sitting in our application into a function. So how do we exactly do that? You might have already guessed it. We start with the keyword function. Start with the keyword function. Then we give it a name, ask the dog's name, ask for the dog's name. There we go. I was like, I wasn't reading that right. And then you've already seen functions a little bit here and there. We end it with parentheses. We'll get more into the parentheses later. And then finally, just like our if statements and our for statements, we need to contain code inside of them. So we use curly brackets, starting and ending curly brackets. So let's actually use the code from the top and bring it into the function below. So what we do is that we're going to just bring in this let dog name equals Stark. And then we bring in this ask the user dot question into the function. Now, really quick, one thing you might have noticed is I did not bring in the readline sync into the function. Do not bring in your requires into the function. They should always stay at the very top of your application or of your file. Always should stay at the top. Biggest thing, do not put requires randomly inside of the application. Put them always, always, always at the very top. If you put them a few lines down, nothing's going to break. Please just don't put them in functions, if statements, for loops, or anywhere else, but at the top. Awesome. All right. And then finally, we're going to do something with this dog name. We're going to use another keyword here called return. So this was a lot. It's a lot. So we're going to go ahead and explore this just a little bit further here. Let's bring it to the next screen. Let's just take it down a notch. We just introduced a lot of orange words there. The first thing that we did was that we need to create a function. So we used the keyword function. The next thing we did was that we say ask for the dog's name. This right here is the name of the function. Just like a variable name, it's up to your creativity. Call it whatever you want. Just make sure that the function name stays unique, just like variables. Function names also have to stay unique. Then next, after that, was something new we haven't really seen with variables, for loops, or if statements. We add these parentheses here. Functions must always end with an open and closed parenthesis. And then finally, we need to contain the code in the function. What contains the code are those curly brackets. And you've seen this again before on if statements and for loops. Finally, we use the keyword return. Return actually brings back outside of the function something back to whoever used it. So it's how we send information back whenever the function is done. Now, return, I really do want to call out, is an extremely powerful keyword. Wherever you put return, no matter what, it will basically exit the function. There is no jokes, mic dropped, it is gone. So make sure wherever you put return, it is exactly where you want it to be, because no lines after return will be executed. If that compiler, remember as we go through in our mind, down line by line, if it sees a return, it's gone out of the function, no question asked. So please make sure we use our return keywords because they are extremely powerful. Final thing I do want to call out here is that return returns something, but it can only return one something. can only ever return one thing. You can't just put comma dog age here and think that is all honky-dory. No, we can only return one thing from a function. All right, that was a lot. So let's dive in. No, I'm just kidding. What we're gonna do real quick now is that we're going to go ahead and we're gonna actually see this in action. So talk with me here, blow off some steam. We're gonna go ahead and create a function out of this stuff up here. To do that, we're gonna do this in Replit here. What keyword do I start out with?
Function.
Function.
Very good, function. And we called it ask the user, or ask for the dog name. All right, so I named the function ask for the dog name. And then what do I need to do?
Parentheses.
Parentheses,
Space and
very
parentheses.
good. Very
Oh,
good,
no
parentheses.
space.
No space. I mean, you can put a space here if your OCD is really getting at you, no worries. I completely understand, but you do not need it. So I would say leave it out of there unless you really want to put it there, but as best practice, just keep it open and close parentheses there. And then finally, I did it for us just because out of just pure habit, open and close curly brackets. Very good. All right, now again, we want to take these 3 lines and make a function out of it. What is the first line I'm going to take and put it inside of that function?
Dog name. Line.
Line 2, very good, absolutely. Line 2, and you know what? I'm just going to take line 3 while I'm up here too, as long as it's not line 1. Awesome. Very good here. So I'm going to do that. I'm going to take those 2 out. Awesome. And just for our benefit, I'm just going to comment out this because we're not using this example right now. So I just commented out line 3 to 8. So awesome. All right. Now what I wanted this function to do then is give me back my dog name. So how do I give back my dog name? What keyword do I
Return.
use?
Return dog name.
Dog name. Awesome. All right. Fantastic. Now let's go ahead and run this application and see what happens. What happened?
Nothing.
Absolutely
Nothing.
nothing, right? Isn't that beautiful? What was that? We have to call them. Oh my gosh, you're absolutely right. How do we call a function? I love when I get transitions. Perfect. Absolutely right. We didn't get anything back inside of this because what we did is we created the function, but the second thing we needed to do was actually call it. So let's go ahead and just see how we do the second part here, call our function. To do that, it's not as even hard as creating the function, thankfully. What we have to do is that we use the name of the function. The name of the function that we created in this example was ask for the dog's name. So if I want to call to a function, I use the name of the function, but then I end it always with parentheses. If you see parentheses at the end of a name, it is denoting that you are calling to a function. That is it, plain and simple. If you see parentheses at the end, you are calling to a function. If you do not have parentheses at the end, you are calling to a property, and hopefully that property exists, or a variable too. So that is what those parentheses are denoting. You are calling to a function. The biggest thing to note is that the function will not run, as we just saw in that example, unless you call to it. Unless you call to it. So you must first create the function and then call to the function in that step-by-step process there. So let's go back over here and try this one more time. All right. Talk me through this here. How am I going to call to this function? What do I do?
You just say the function name, ask for the dog name.
Ask for the dog name. Very good. Yes, ask for the dog name. Awesome, awesome. I keep just doing it by habit. All right, I said the name of the function. I know no one saw what I just typed. What's after that? After the name of the function, what do we include?
Parentheses.
Parentheses, very good, because this is denoting, again, a function call. You are calling to that function. Awesome. So now we actually have that in there. So we go ahead and return this, or excuse me, we rerun this and look at on our right-hand side now. What is your dog's name? In this case, I'm going to just type in Bella. And Bella it is. Bella is returned. Remember, this is not actually from JavaScript. This is from Replit. There is no console login here. Sorry for the confusion.
So this is a little confusing, Kyle, because you have the ask for the dog name before the function, And then sometimes when I put things before, like the stuff, it says like you have requested something that's not here, so you have to move it. So as long as the function is made, I can ask for it anywhere?
Yes. Yes, you can. And I have been loving your transitions today. Let's go ahead and dive into what exactly the computer is thinking here. Because I know that maybe a couple of you might be kind of mad at me because I've always promised you sequentially. So let me try to settle my case here before everyone comes to, luckily I don't tell my address because of this exact reason. There'll be like pitchforks and torches out front because of all the times I've let people down there. So let me go ahead and talk about this. Let's bring in what we just saw there. Now, this isn't exactly what we saw. I have the ask for dog's name, but we're going to talk about why that actually worked on the other end there. Real quick, I'm just going to finish up this example here because I forgot I said that. So const my dog's name equals that. Remember, it is returned. That's what I wanted to show here. Remember, our dog's name is returned. If this thing returns something, that means I can catch it in a variable. So I console log this here. My dog's name. Like that, and I run this again. I say Toby, it prints out Toby there. Because again, this is my dog's name. My dog's name now is assigned to Toby after line 10, comes down here and prints out console log. Excuse me. So this is the final little thing I wanted to show you. So let's go ahead and deep dive now, not really deep dive, shallow dive, which is not safe, into why exactly was I able to put that function call above where the function was actually defined. So when the computer, or when your application starts up, what it's going to do is look for two things. It's going to look for these requires, is why we have that at the top. It's going to look for the requires and bring it into your package, or bring it into your application. So first it like looks at the read line sync. Awesome. It's like, okay, cool. Read line sync is there. I'm going to bring it into there. And you've seen that before. You've seen that little white printout on Replit on the right-hand side. That's it installing read line sync. And then it's going to do a second thing. It's going to look for the functions. It's going to say, okay, this user right here has created some functions out there. So what I'm going to do for them is remember those functions in my head. When it uses the function keyword there, again, when it uses the function keyword there, it's saying, hey, remember this function always throughout my application. As long as my application is alive, remember this function here. So that's at step 2. After that, it's ready to run. So it actually starts running the application. When it does that, what it's going to do is that it's going to come down here, it creates it and remembers it. After it does that, it comes down here and actually starts running your code and says, okay, I see down here on this line, you just called for ask for the dog's name. Now remember, I told you that code always goes sequentially, and I promise you it does. Think again for IKEA tasks. If you have to put together a couch, sometimes those instructions are always going sequentially, but then it says flip to Appendix B to see how to put together the ottoman or whatever. What you just asked for the program to do is flip to Appendix B, aka go up to the function, ask for the dog's name, and run that. So now it's actually going to run your function. So that's what happens here. Now this function will go sequentially. It says, okay, I'm going to run it because I was called. So let the dog name equal start, ask the user a question, what is your dog's name? And then finally, it returns the dog's name. Once that happens and it sees that return, again, what happens? It gets out of there. Full mic drop, no questions asked. It goes right back and returns Stark. Once it returns Stark on the right-hand side, it's assigned into my dog name on the left-hand side. So here, my dog's name is set to Stark. And then finally, we know this one, my dog's name is printed out. So that's how this is exactly working. This is what the computer is doing in its head. So I know that was a lot. So just take a breath. Take a breath. It's okay. Functions are a weird bean. So all good. So before we talk about it, write down your questions if you got one. Just take a deep breath. It's a lot of information we just thrown at you. All right. We'll go into it a little bit more, but real quick, just to help everyone out here, we're going to answer a couple questions. Oh, there we go. Awesome. All right. Help me out here real quick. A peanut is not actually a nut. It is a what? Does anyone actually know this one?
Legume?
A seed?
It is a seed. Okay, are you somebody's downloading these slides beforehand. I need to start changing these up.
I'm
Very
not.
good. Whenever someone knew Octothorpe, I was like, how the heck did someone know Octothorpe? All right, Mars might not be the largest planet in the solar system, but it has the largest what?
Mountain.
Moon. It is mountain. Very good. Mount Olympus. It is 15 miles tall. That is how I won one round of trivia in my entire life, as I knew that answer. Very proud of myself, right? Yes, 15 miles. 3 Everests. 3 or 4 Everests, I forget, that can fit inside of it. The tiny pocket found in jeans were originally designed to hold a what?
Lighter.
A what?
A lighter.
A lighter. I don't think they
Matches?
had those back in the day. It was actually a pocket watch. It was not a lighter. It was a pocket watch. I love it. I love it. Awesome.
What's left of your paycheck?
Oh, amazing, amazing. All right. So let's get back into the big reality here. Let's talk about the function. So first, before I continue on there, I do want to take any questions we have about functions. So anything that we just went over here, we'll go back over to our example. What are we looking at functions here? What's going on in everyone's head?
So just the answer to my question before was just that when you hit return dog name, it calls the function no matter where it is, or when you call a function, it doesn't matter where you put it because it'll just go to where the function is and then say, oh, now I can call it, right?
Yeah, so okay, so think of when I press this run button, 2 steps happen. It compiles and it runs. Those are the 2 steps that happen every time you press that run button. It compiles and it runs. When it compiles, it will see what you've created. It will see your function that you've created. So basically just see what you've put out for it. So it says, oh, you see I have a read line sync and I see that you created the function ask for the dog's name. That's compiling. And then it runs your application. When it runs it, it doesn't matter where you put it because it already knows what ask for the dog's name is because it found in the first step. So the second step, it says, okay, I know what ask for the dog's name is, so I'm going to run this. So to answer your question, if it makes you feel better, honestly, just put them above there. It's A-okay, but I wanted to let you know why it works. I usually don't actually put it above the function call because I don't want to deep dive into that conversation, but I'm happy that you found that. It's kind of just one thing I wanted to show. But if it makes you all feel comfortable, please, please, please put your functions at the top. It is okay. It depends on how the how your assignments look, but that is one way you can do it just to help our heads just manage all of that new stuff. So it's all good. But does that kind of help out, Beasia? Okay.
Can you explain reverse functions that were in the textbook this chapter? I was trying to use them in the exercise and I couldn't get it working.
So reverse function, is it reversing an array? Is that what it is?
The palindrome.
Yeah.
Okay, so okay, so I don't exactly know the specific examples in the textbook. So was it reversing just reversing a word, or what was it just reversing?
So I was trying to use it to I was trying to do 2 functions at once and reverse what was it? Essentially, was it stairs of like a pound sign, and I was trying to reverse that function. There was a function for make an isosceles triangle.
Isosceles triangle, yes.
Okay.
And I was trying to reverse that so that I could make
reverse is an array method.
Yeah.
And so if you want to reverse a string, you have to split it and then reverse it and then join it back into a string.
So for this particular example, it looks like, I believe, Annie, you're talking about the reverse characters in 10.11.1. Is that correct?
Yes.
Okay, so for reverse characters, and Raiden, you're absolutely right. Reverse is a method that you can use on a string, but it looks like what the example that we're talking about here is reverse characters. So reverse characters is, you're absolutely correct. It is a function, but it takes in a parameter. We haven't yet talked about that, so we absolutely can do that in a moment. But yeah, we can talk about that. What it's going to entail is using a for loop in the reverse direction. So we can definitely take a closer look at that here in a second, Annie. Is there a particular question about it or anything about functions in general, or just kind of that particular use case?
Just how to do it, because when I was doing it, it wasn't working.
Gotcha. Okay. All right. No worries there.
Kyle?
Yes. Yes.
Like, suppose in the function, in the one you just wrote, the dog's name function.
Yeah.
Yeah, before the return dog name, suppose we have a couple of console log statements. Would they print out or no? They will, right?
Oh, if you put them inside the function?
No, if there were some other console log statements, like before the return statement, like on between 5 and 6, line 5, yes.
Okay, so inside the function, awesome. Yeah, absolutely. If we put a console log and we just said, hello there, absolutely. If we ran this again, we type in, who's got a dog name? We got a dog name?
Peter.
Peter, all right. Nico, oh, I do like Nico. All right, yes, it does. It prints out hello because it still sees that. Remember, it gets called down here, and then we start going into our function, and we do it sequentially. So we say dog name equals Stark. We ask the user for their dog name. We print out hello, and then we return the dog name. So that's why we see hello up there. So you're absolutely right. You can put console logs inside of the function.
Thank you.
Absolutely.
Can we write a function without return statement?
Yes, great question. Absolutely. So a function can return one thing, but it doesn't always have to return something. If we just wanted to return nothing in here, we absolutely can. We press run here, and we say whatever we want to do. I heard Nico. I love the dog name Nico. So we still print out hello, because hello is here on line 6, and then we return nothing. Now you can see it very faintly. My dog's name is still returned something, but it's returned this word called undefined. Undefined is something we haven't really dove too much into, but it basically means nothingness. Think of it as a black hole. But in programming, nothing is still something. So we have to tell it nothing is returned, aka undefined was returned. So dog
now you said
yeah.
Now you said the return statement is for the user or the person making the function. So the return statement, I shouldn't think of the return statement as like a block statement. It's more or less like a channel which the info goes through, right? Because you said the info is returned to who? You said first, you said it's like the return statement has two purposes. I guess it stops the execution, the flow of information of the function, but it also returns. It also returns a certain amount of information.
So yeah, how about this? If I asked you to get me, or actually, I'm trying to think. Yeah, if I asked you to go get me Gone with the Wind from the library, I just asked you to do a task. So you go to the library, you check out Gone with the Wind, and then you hand it back to me.
Okay.
In that case, when you hand me back the book, you just returned me the book.
Okay.
So what you just did is return me a single book, a single piece of information back to me. That's return. And you yourself are the function. You got the book I needed to get, you went to the library, and then you gave me back the book. When you hand me that book, that is the return keyword at work. You returned me the book. So return is the keyword to deliver that information back to who originally asked for it. And that asking for it is when the function is called down here.
Will there ever be a case where you won't need to return it? Like, is that even applicable?
Yeah, absolutely. Yeah, you can definitely still, functions out there will return nothing. That is absolutely viable. Yep.
Okay.
So remember, functions are just tasks. You ask the computer to do something, it does it, and it gives you something back. If you have to, if your parents ask you to, yeah, go ahead.
Functions can be combined, right?
You can do with functions within functions. Yeah, absolutely.
Okay. But combined functions will only have one return statement.
Remember, every function can have return one thing. So if you have 3 functions within a function, everyone can still return something. So if you have every function that's in that function can return something. And then the one big function that wraps all those 3 functions still can just return one thing. But we won't get too much into functions inside of functions just yet. So please don't blow up your heads. You are on camera. That is a lot to do functions and functions. Just remember, functions are tasks. You are running to the grocery store. You are getting grapes for whatever reason, and you are returning the grapes back. That is all a function does.
You said we're returning something, you're returning the grapes back, but on occasion functions do not return items as well.
Exactly. Maybe you're returning the grapes. Say like, okay, I didn't want this book. You give the book back. All the book does is like goes back to the book to the library, and I come back empty-handed. There's still tasks like that too. When you're trying to return clothes you bought or something like that, there's still tasks out there that you don't come back to the home with anything. So just think of it as that. Remember, we're just running tasks out there. That's what this functions thing does. So it runs tasks. But if something needs to be delivered back, the return statement is the statement you want to use. Now, let's pause here just for a moment, and let's go ahead and do one more example before we keep going with questions. So with this, we had 2 examples in this class. Help me out with just one more here. We're going to be checking for Toby. We're going to create this code here into a function. To start creating the function, what keyword do I use?
Function.
Very good. Function. That's how we start creating it. In this case, I'm going to name it for us. It's going to be called just check for Toby. But yeah, you're absolutely right. The name of the function is next. Check for Toby. And then what do I start with? What's the next thing I need to put? Parentheses. Now in this case, we're going to be switching up a little bit. Remember, up here in the top, we have the my dogs array. If I just want to check any array for Toby, just make sure that little stinker didn't escape. I want to make sure that it is more customizable in that sense. So you're absolutely right, though. I need to start with parentheses, but I need to take in something. I need to give this, I need to give this function a parameter. In this case, I'm going to call it array of dogs. So ARR of dogs right there. And then I'm going to close my parenthesis and then bring all that code back down just like we did before. Now, take a pause here. Take a look at what we did. We said function, name of the function, check for Toby, and then we included array of dogs, a parameter inside those parentheses. The parameter is something that can be passed in the function so it can use it. Just like in the library example that we had, I asked for a specific book, a book name, to go get from the library and return it back. I gave a parameter out in that request to that task. In this one, array of dogs is what wants to be looped through. That being said, right here for my dogs.length, my dogs doesn't really exist anymore. Pretend this line up here doesn't exist anymore. We want to actually loop through the array of dogs. So inside of these curly brackets, we want to actually utilize what's inside of these curly brackets. In this case, the parameter. The parameter is only accessible inside of the curly brackets of the function. So for my dog, we don't actually want my dogs.length. We want the thing that we're actually passing in to the function. That thing is the array of dogs. The array. And we say array of dogs dot length. So now we're actually utilizing the parameter. Now one last thing, as you already pointed out, we have functions out there that don't need to return anything. And we're looking at one right now. If we find Toby, we just console log Toby who let you out. We don't return any information back to the person who called us. So in this case, we just put the keyword return down here. Return it down here just with that semicolon. So remember, the return is technically optional. You don't always have to return anything if you don't want to. It's there if you do. You can only return one thing if you do. So this is right here how we can write this code. So let's go ahead and take a look at it actually up here. So what I'm going to do is I'm going to just comment out our 2 little lines right here, keep our function up there, and we're going to uncomment out this. So help me writing this again. How would I start translating this into a function? What keyword? I think function. Very good, function. I'm going to call it check for Toby. And then we start with the parentheses, but what do we want to again include in these parentheses?
Array of dogs.
Array of dogs.
Array of dogs. Awesome. So also our parameter names are also up to our creativity. We can again call this cookie if we wanted to. We just have to use cookie within the curly brackets. This is an arbitrarily arbitrarily named parameter. I'm trying to keep my words straight here. So in this case, I'm going to call it array of dogs. And then I'm going to bring in my for loop down here. I do that. And then what was the last thing I needed to change here? Because I wanted to use my parameter properly.
Instead of my dogs dot length, you have to put array of dogs dot length.
Very good. We need to put array of dogs here, the actual parameter name. Now, if I run this, what's going to happen?
You didn't call the function.
Nothing.
Very good. Nothing. Absolutely right. So help me out with this. I'm going to keep, again, my functions at the top so we don't get any headaches, if not already, tonight. So we're going to come down here. Help me call this function. What do we do?
Check for Toby.
Check for Toby. All right. Check for Toby there. Parentheses.
Parentheses, my dogs.
My dog.
Very good.
My dogs.
We need to plug in our argument here now. Basically, arguments are the things that you plug into the parentheses there, and the parameters are here inside of the function. But yes, you're absolutely right. We need to plug in what we need to pass in to the function itself. Information is my dogs here.
My dogs.
Awesome job. Now we can actually go ahead and run this. And perfect. We run that because we just passed our array into our parentheses. So this parentheses passed over to this function, and now it says Toby, who let you out. Let's go ahead and double check. Let's take Toby out of this and run it again. And now we don't get anything because we took Toby out of the array. Whatever we want to put in this array, and we passed it in there. Now, this is very, very weird. We're able to pass in information into these parentheses, and then somehow it magically gets there. So this is extremely weird. So let's go ahead and just kind of see exactly, again, what is going on in this computer's brain. Let's start out with the function. What happens on the round one is that it's going to find this function and create it. Then we come down here to my dogs here for the array, and we create the array of my dogs, Bella, Stark, and Toby. And then finally, we do that fun thing. We call to the function by using the function's name. Now remember, we use my dogs here. My dogs is the actual variable that's right above it. It doesn't have to be right above it, but it has to be in the context of where it's at. So yeah, we say my dogs. Now here's the fun part. Once that's called, it goes up to the function check for Toby. But my dogs, that information that's sitting in that variable, remember data's inside that variable, it gets transferred up into the array of dogs. So whatever information is in my dogs is technically in array of dogs. It's passed up there. It's the same stuff. It just goes up there and it's sitting right inside of array of dogs. So now when it's going through, it's going to loop through Bella, Stark, and Toby. That's sitting in the array of dogs that came from the variable my dogs. That was a lot there. I get it. Well, let's take a look at what happens in the for loop then. It goes through the for loop and eventually it finds Toby and it prints it out. And it says, Toby, who let you out? And that is when it comes back here and it returns absolutely nothing and finishes. So the biggest thing to remember is that the information flows up into that parameter. Whatever you pass inside those parentheses, it flows up into the function parentheses up there. And that is what we can use. So it is absolutely, absolutely imperative that if our function calls for a parameter, it is absolutely important that if our function that we are using is calling for a parameter, we plug that in to the parentheses, whatever it's asking for. In this case, for check for Toby, it's asking for an array of dogs. Therefore, down here, we pass it in an array of dogs, which just so happens to be called my dogs here on line 18. And when that happens, the information comes and flows right up here to the function, and the function uses it as such. This is how parameters are used within functions.
If there was nothing inside of the parentheses after check for Toby, would it still do something? Or I'm sorry, up in the function.
If we did that, so take that out instead.
Mm-hmm.
If we took out we took out this parameter here, array of dogs. So what's going to happen here on line 11?
Oh, okay, I see. I got you. It doesn't know what it's referring to at that point.
Exactly. We're going to get rid of that. You can still pass this in. It won't even get down to this line really. But yeah, you can pass in my dogs, but it'll come up here. We're using array dogs. It's like, I have no idea what that is. So you'll get error there. Awesome question.
So I have a question too.
Yeah.
So with the array of dogs, so I'm used to us like assigning, you know, a name to something. Where did array of dogs come from?
You're used to assigning a name to something, and that's exactly what we're doing here.
Okay.
We are creating a placeholder for information, just like a variable. The only thing that's missing there that you have seen before is like a let, but we don't put lets in there. For parameters, it just automatically assumes that it's going to have a let there anyway. It does it for you. But what you just did is created a variable, a placeholder for information to be passed into it. And so that's what's happening. The information is being passed in that placeholder. So you are declaring or setting up a variable there. It's just more of a, I'm ready for information. Pass it to me whenever you want. And that information being passed is down here. It's when we put information inside those parentheses.
So since parameters are like let, they're not necessarily they're mild, which means they can be used again. They're not like constant.
Okay, so real quick, Kansas, yeah, does that help?
Yes. And
Okay.
then I'm like trying to do like the rest of it because you know it's still not 100% clicking for me, but I'm getting it more and more. So.
Okay. Awesome. All right.
I'm
And then
so
I'm sorry.
lost.
Give me 1 second there. And I'm sorry, I cut you off there. I apologize. What was your question?
So parameters they're not static. They can be used again. Once you store the information, they can still be manipulated. Just like you said, they like let. Like when you declare a variable with let, you declare when you set a piece of code as a parameter, it can be used again.
So you're saying the parameter here, array of dogs, can be used again?
Yeah.
Technically, yeah.
I mean,
You could set it
can be changed. It can be manipulated.
Technically, yes, it can. So I wouldn't ever, I mean, I can always say array of dogs is now equal to just Stark. Right here. But when I run this then, it's not going to ever do anything, no matter if I put Toby in here or not. So I wouldn't want to, you don't want to do that. It is possible, but you typically wouldn't want to change your variable or your parameters. So the possibility is there, you just wouldn't want to do it. It's not recommended. So again, it's a let. But okay, so I heard another question out there too. Hopefully that helps out a little bit. But yes, heard another person that is completely lost. So just kind of trying to get your take, if you're still out there.
Yeah, that was Tracy Ann. And I guess because I'm having a problem with the way that you were showing it on the PowerPoint presentation, the code that you've written down versus how it's now showing up in the Replit, I'm still getting errors and I'm trying to figure out where it is. So I think that because it doesn't necessarily match and I'm having a hard time tracking it, I'll take it into the sidebar with my small group and I'll ask the question that I have there. This way we can proceed with the lecture.
Okay. Okay. Well, luckily for everyone here, I am done. So that's why I was taking a couple extra questions there. So I'll go ahead and pause, I'll go ahead and pause talking here on my side for a moment, and I'm happy to take a couple more questions about functions in general, if we want to deeper dive into something.
And what happens if we call that function without the argument?
If you call this function without the argument, what's going to happen is that it's going to get pretty darn upset. What it's going to say is that it can't read property of undefined. Remember, if we don't pass in anything or nothingness is called undefined in JavaScript. So what we just passed in here is nothing, aka undefined. Comes up here, says undefined. Down here, undefined is not an array. So it says, I have no idea what length is of undefined. So if you don't pass in any information, you're passing in nothingness. Remember, still encoding. Yeah.
If we are not using that array of dogs in that function, will this same error come? If you're not using at all in that function, if in case.
So you're saying you're not using array of dogs?
Yeah.
So it would act just like this. We don't have any parameters up here. Nothing's using it. So if we don't have array of dogs here, we say, well, oh, I forgot one thing. Dang it.
And no, we have array of dogs in the definition of the function, but we are not using it inside the function. So will this save error?
For that case, no. If we're never using that parameter, we're all okay then. So if I just commented out all the guts of the function there, nothing happens in the function, but we're still passing information. It's basically like shouting into the abyss, like do this, but they don't do anything with the information. They just ignore it and do whatever they want. So yeah, that absolutely works.
Okay.
I'm gonna type in my dogs here. And one more thing I forgot here at the very end, I gotta do array of dogs. We're checking the wrong thing. There we go. All right, awesome. Oop, what is that? Oh, yeah, okay. Awesome. So, yes, functions can be a bit tricky. And they are a lot. They're also a huge part of JavaScript, which is why it's absolutely important to just keep looking at this and just testing them out on your ends. If we wanted to, we can always run them in unison. So we say check for Toby. We can say ask for the dog's name after that. Just like that. So we say const dog name. That. So now if we run this, what it does is say, Toby, who let you out? We say, what is your dog's name? We can say Tina, so why not? And then we say hello. So that. We're going to take out there now, and we're going to go ahead and keep returning the dog. Then we're going to put that back to the original example. Awesome. All right, one last thing I guess I will show you in the last few seconds we got. What if we wanted to inject Toby into this array? So for this one, we have my dogs. So we say my dogs dot push. We say the dog name. Just want to show you guys this example real quick. So what we're going to do is that we're going to ask for the dog's name. We're going to say Toby or whatever dog name. It's going to check, or it's going to have this my dogs array created. We're going to push the dog name into that array, and then we're going to search it for Toby. Little stinker. So what is your dog's name? First, I'm going to just put, well, let's go ahead and do just Toby. And then it says Toby, who let you out. Let's go and run this again. Someone give me a dog name that's not Toby.
Rumpelstiltskin.
Oh, gosh.
Chip.
Zoe. I heard Chip. I keep going until I hear one that I can spell. There we go. And now when we type in Chip, nothing gets printed out. Again, if we type in Toby, what happens is that it gets injected into the my dogs array by the dot push. And then we check for Toby. I said Toby, it's in the array. Therefore, we're going to get that Toby who let you out. So this is a way we can, yeah, what's up?
Sorry. So for hypothetically, if you typed in Toby all lowercase, would it not print anything out? Would you have to do to all lowercase somewhere in the parameters?
If we're looking for that kind of, if we're looking for any way we spell Toby, yes, you're absolutely right. It will have nothing to do with everyone out there. It will have nothing to do with functions. We're just talking about the conditional now here on line 11. So yeah, you're absolutely right. If I run this again and I type in Toby lowercase, it will not print out anything because our conditional is looking exactly for Toby capitalized.
Gotcha.
Awesome. All right, any final questions?
Kyle, so even if Toby is not present in the array of dogs, still the function runs, right? It's just that it's not displaying anything.
Right, because we're just performing a task. Remember, again, functions are just tasks. If the library doesn't have Gone with the Wind, nothing is returned. It's just, but we still go to the library. So we still do the task. So yeah, sometimes things won't be printed out, but the task still definitely runs.
Like if you put an else statement, then we can know like there's no Toby here or anything, just to see like the function is running.
Yeah, absolutely. So what we can say is that we say else console log. What I'm going to say is that array of dogs of I is not Toby. There we go. So we run this. What's your dog's name? It's going to be Peter today. And what we see is Bella is not Toby. Stark is not Toby. Peter is not Toby. So we see that this loop is still going. It's still iterating, checking for Toby, but not finding him. Which means Toby is still in his cage, which is perfect. Don't let Toby out. So awesome question. Does that help out, Hannah?
Yes, thank you very much.
Yep, absolutely. All right, which is perfect timing there. All right, everyone, you all did a fantastic job. No one yelled at me, cursed at me. Maybe, I don't know. I'm not seeing everyone's windows out there, but I am just so happy you all made it through without any big issues. I do have one like unread message out there. You know what? That's probably it. But in general, you guys all made it to the end. This was functions. This is a very tricky concept, but it is the last essential building block of JavaScript in every programming language in general. Functions are how we can just split up all those tasks that we have to do because applications do a lot of them and make something from that. So as always, thank you guys very much for making it to the end there. Just all the participation, all the questions, absolutely love it. From that, don't forget, Monday we have the next class. Have a fantastic weekend. Enjoy your studio. We'll be doing that studio review here at 8 p.m. And other than that, enjoy your night. Have a great one, everyone.
Thanks, Kyle.
Thank you.
Thank you.
Thank you all.
Bye.
Thanks.
Thank you.
Hey Kyle, I had two questions that I wanted to ask at the end, just because like I didn't want to keep holding up anybody. But so when we were talking about grading the assignment, right? So I submitted part 1 to the assignment a little bit late. Am I able to submit part 2 before part 1 has been graded? Because it's not been graded
I believe so.
yet.
Yeah, I believe so. You can just add the link to all of them. The biggest thing is just submitting that final assignment on time.
Right, because I did notice that whenever you forked the replit again, it would create a different instance of the same code. So I just wanted to double check there.
Yep.
Awesome, great. And how long do you think it would take them to grade that? Like,
for the auto grader or for
like the TA to go in there and like let me know if it's done right or not?
Oh, I would definitely stay up to date with your TA. Ask them in your small groups, like, hey, I have my assignment turned in. Can you get this graded? I just want to get everything done. They should.
Okay.
Yeah, they'll be the ones who can answer that question. Just
Awesome.
Let them know that it needs to be graded.
And then last question. So I know you were saying that. Let me see if I can find my notes here real quick.
What I'm going to do here, I'm going to stop the